Hi everyone, I'm going to go over Wednesday's warm-up, and then I'll post a video on Friday for Thursday and Friday's warm-up. So today's objective is I can determine if relationships are proportional or non-proportional. The ratio of boys to girls in Mr. Johnson's after-school club is the same as the ratio of boys to girls in Miss Green's after-school club. So there are 4 boys, and 12 girls in Mrs. Johnson's club, and there are 6 boys, and you want to know how many girls. So to do this, as I already did without even realizing, you set up a proportion. Okay? Instead of question mark, we would use X. Now I just used B and G to represent boys and girls, so if you want to write it without that, this is what it would look like. And then from there you cross multiply. 4 times X is 4X. 6 times 12 is 72. 72 divided by 4 is 18. So X is equal to 18 girls, letter D. Okay, today's review lesson is on proportional and non-proportional relationships. We have a couple different types of questions here. So example 1 is using tables. So is this table proportional? To figure out if a table is proportional or not, you need to divide y by x. Make sure you're dividing y by x, not x by y. That happens a lot. So we would divide 6 by 7 in this one, 12 by 14, 18 by 21, and 24 divided by 28. If we get the same number each time, that's called a constant rate of change. If we get a different number, then there is no constant rate, and we end up, well, we'll talk about that. So let me do this. So it looked like they were all the same number. The decimal was nasty, but they were all the same. So since they're all the same, this would be yes. The table is proportional, and our reasoning, because there is a constant rate of change. Now the second question asks, what is the constant of proportionality? Hopefully you remember the constant of proportionality is the same exact thing as a constant rate of change. So we kind of found it. Let's just use the fraction, the simplified fraction, instead of rounding a decimal. So we could say 6/7 is the constant of proportionality. Now I'm going to add this little extra. Hopefully you guys remember writing an equation. The equation would be in the form y is equal to k times x, where k is that constant. So our equation here would be y is equal to 6/7 times x. All right, example 2 is a graph. We don't really have to do much for a graph other than if it's proportional. We have to find the unit rate. So hopefully you're thinking, oh, I know that this graph is proportional, or I know this graph is not proportional because of 2 features. In order for the graph to be proportional, oh my gosh, whoops, has to be a straight line and start at the origin. Okay, this graph appears to be completely straight and starts at the origin. The origin is 0, 0, and that's exactly where this graph starts. So yes, this graph is proportional because the reasons I just said, it's a straight line and starts at the origin. You do have to be able to explain that. All right, so if so, what is the unit rate? Usually, you guys have been pretty good about determining if graphs are proportional or not, but not so much with finding the unit rate. When you find the unit rate, you're looking for where x is equal to 1. So it's this dot right here. Let me zoom in. And these are counting by 2's, which means this would be 1. This would be 3. This would be 5, 7, 9. And since this is 10 and that's 20, this would be 15. This would be 5, 25, and so on. So here is the unit rate. The point is 1, 5. Now, the unit rate itself is not 1, 5. That's just the coordinate that represents the unit rate. The unit rate itself is 5, gallons per minute. Okay, hopefully that was a pretty good one. Next up is writing a proportion, just like the warm-up. So you were able to purchase 5 gallons, keep doing that, of gas for $19.85. How many gallons did you buy if you spent $47.64? Set up a proportion to solve. So 5 gallons of gas costs $19.85. That's in money. And you want to know how many gallons, so question mark, if you spent $47.64. So $47.64 would go on the bottom because it has to go next to wherever you put money. And then X gallons would be on top. Okay, so from there, let's cross multiply. 1985 times X, and 5 times 47.64 is 238.2. Divide both sides by what's in front of X, aka 1985, and you end up with 12 gallons. All right, and those are the 3 types of questions mainly that we deal with when it comes to proportionality. Whoops. So you're on to independent practice. So you have 6 questions, and all of them are asking basically what's the COP, constant of proportionality, or constant rate of change / unit rate. It's the same thing. Remember when we talked about this? CROC is the same as COP, is the same as unit rate. There's some with proportions, there's some with graphs, there's some with tables. Okay, these are the ones with proportions. All right, so good luck. If you have any questions, please let me know.